let's start with the formal charge. Formal charge, this is the, um, it is having the very simple formula. Formal charge is the, uh, uh, you have to calculate by using this small formula, valence electrons minus electrons in lone pairs. Lone pairs. Lone pair mean which are not bonded and free in the molecules, and minus half number of the bonding electrons. As you know, in the structure which we have already uh, drawn before, there are only involvement of the three type of electrons are there. The first is the valence electrons. You have calculated the valence electrons. Then there are some unpaired electrons, and some are the paired electron or whatever the bonding electron. So this is the bonding electrons. Okay, let's. So I'm going to calculate the charge, formal charge, by using the same formula, and the formula is here. This is the uh, nitrate. Nit. So, so nitrate we have already plotted. This is the NO3 double bond over here, and then this is the one oxygen, single bonded oxygen, and there are the six electrons over here, unpaired electrons, and similarly there are the four electrons. And this molecule is having the minus charge. If the charge is not written over here, you can also calculate the charge. That's why this is called the formal charge. Which formally charge is going to exist in this molecule. So let's see the first is the to calculate the formal charge of this number nitrogen. I am placing just to differentiate between this oxygen and this oxygen, because this oxygen is having double bond and this oxygen is having the single bond. So I am just using the number one. So it is easier to calculate how many valence electron are there in oxygen. Of course, there are the six valence electron, because each oxygen is placed in six group. That's why it is having the six electrons. Then electrons in lone pairs. Lone pair mean which are not bonded, and there are how many electrons are there? There are the four electrons are over here. 1, 2, 3, 4 minus, and then this is the half from the formula, number of the bonding electrons. The bonding electrons are there, and each bond contributes to the two electrons. So there are two bonds. That's why there are the four electrons are there. So you just have to multiply the two with the bonds which are available in the molecule. There are two bonds. That's why the number of electrons should be the four. And you have to cancel out this one. That would be equal to 2. And 6 minus 4 minus 2, that would be equal to 0. So this oxygen is having the 0 formal charge. Similarly, you can do for the second oxygen. If I say what is the formal charge for this oxygen, again valence electron will be the same, minus how many lone pairs are there, 1 2 3 4 5 6. There are the 6 valence electron lone pairs of the electrons, minus this would be the half. And how many bonding electrons there, because there is one bond and one bond contributing the two electrons, and that's why this is the 2 is going to cancel out. So what would be the answer? 6 minus 6 minus 1, that would be the minus 1. So this oxygen is having the minus 1 charge over here. Let's see. And similarly, because this oxygen is similar to this oxygen, of course it would also having the minus 1 charge. Now the nitrogen is left. I'm going to calculate the formal charge for the nitrogen. And how to calculate? Again, how many valence electrons are there in the nitrogen atom? There are the 5 valence electrons, because nitrogen belongs to the fifth group, minus how many lone pairs of electrons? There are no any lone pair of the electron over there, because all electrons are in the bonding form. So there is no lone pairs of the electron in case of the nitrogen, minus, then it is the formula, minus half number of the bonding electrons. How many there are the number of bonding electrons? You just calculate the number of bonds. There are 1 2 3 4 bonds, and there must be the 8 electrons. So you have to multiply by the 8. And now to cancel out this one, that would be the 4, and the answer would be 5 minus 4 will be equal to 1, and that would be the plus 1, because this is the plus, this is the minus. So this is having the plus 1 charge. So this is the final form of the molecules. You have correctly calculated the formal charge on each element or the atom present in this molecule. Now remember, the formula of the nitrate is 3 minus, it was like this. So if you want to calculate the total charge in this molecule, you can simply say this is a plus 1 minus 1 minus 1. So there is minus 2 plus 1, that would be equal to minus 1. So it justify the answer what is the the charge on this nitride. And if it is the minus 1, that means you have rightly calculated the formal charge on each of the atom present in this molecule. So this is all about the formal charge, how to calculate the formal charge over here. I'm just repeating another very simple calculation by using another example. Let's suppose I'm going to calculate directly the formal charge by placing the molecule. Let's suppose this is the BH4. This is the boron, and the structure would be like this. Boron, there are the 4 hydrogen. So, and this hydrogen, and this. So again, formal charge for the hydrogen. There are only valence electrons, because hydrogen belongs to the first group. Then you have to subtract the lone pairs. There is no any lone pairs, minus half. How many bonding electrons there? There is one bond, so the electron would be the 2. So 2 divided by 2, that will be equal to 1, and 1 minus 1 will be equal to 0. So that means this hydrogen is having the 0 formal charge, and this is the same. This is also having 0 formal charge. This is also having 0 formal charge, and this is also having the 0 formal charge. Now, what would be the formal charge on the boron? and boron belongs to the third group. That's why it is having the 3 valence electrons minus how many lone pairs are there. There is no electrons are there in the form of the unpaired. That's why it is having the 0 valence unpaired electrons minus half is from the formula. And how many bonding electrons there? Boron is bonded to 4 hydrogen, 1 2 3 4. There are 4 bonds. That's why the electrons would be the 8. Now you just simplify this one to 4, and the rest answer would be 3 minus 4 will be equal to minus 1. And that's why this is boron is having the formal charge of -1. And what would be the net charge on this molecule? That would be all hydrogen are having 0 charge, and there is the minus charge on the boron. That's why the net charge would be the minus over in this molecule. So this is all about the formal charge.